Okay, now that we've done normal CDF with these sort of questions, we're going to go into applications, and there is still Z-scores to cover, but we'll come back to that on a needs basis as we do the application questions. So we're just going to skip this, and when we come to the relevant question, come back and show how it's using that theory. Okay, so the application, if we go all the way down to 7F6, I'm going to do question 1, because 1, 2 and 3 are similar. Then I'll do question 4, which is a different style of question, and 4, 5, 6, 7 are similar. And then I'll do question 8, because it's another different style, and 8, 9, 10 are similar. Okay, so 7F6, this is the length of bolts produced by a machine. They're normally distributed with a mean of 19.8 and a standard deviation of 0.3. We have to find the probability that a random selected bolt will have a length between these two values, 19.7 and 20. So the first thing we'll do is put all that detail down and relate it to a graph or sketch of the situation. So 7F6, question 1, we have a normal distribution of, well, that's not too good, let's start again. Okay, 7F6, question 1, we have a normal distribution, and the mean of that distribution is 19.8. That's the average length of bolts produced. So we can put mu, which stands for the population mean. That's 19.8. The population mean being the mean of the bolts of the whole factory. Even though we've only selected a small sample, they tell us in the question that's the mean of the whole length of the bolts of every bolt produced. And the standard deviation of the whole population bolts produced in the factory is 0.3. Now, of course, we can't always get the exact standard deviation, so they are estimations. We're assuming that the 0.3 is the standard deviation of all the bolts. We want to find the proportion of bolts that are between 19.7 and 20. So it's this proportion in here, that area in there. Okay, so to find that, we simply use our normal CDF. So we can go the probability of getting a random bolt between 19.7 centimeters long and 20 centimeters long is equal to normal CDF. You put in the lower value, you put in the upper value, follow it by the mean, and then the standard deviation. So you put that in the calculator. So you go second distribution, and normal CDF, number 2, put in the lower, 19.7, and then put in the upper, which is 20, and the mean is 19.8, and the standard deviation 0.3, and go down to paste the answer. It puts the syntax in the home screen, press enter, and so answer is 37.8%. So 37.8% probability that a random bolt will have lengths between those two lengths there. Okay, now the rest of those questions are similar using normal CDF. Now we'll jump down to question 4, which is going backwards. So writing the question down, we have a physics test and the mean, the average score, was found to be 46. The standard deviation was found to be 25. So on average, students get 46. Could be out of 100, we don't know. And standard deviation being 25. That gives an idea of the spread of scores. Remembering 68% are between plus or minus 1 standard deviation, plus or minus 25. 95% are between plus or minus 2 standard deviations, that's plus or minus 50. And almost all of them are between plus or minus 3 standard deviations, which is plus or minus 75. Okay, what we need to do is, if we draw a distribution like this, our mean is 46, and it says an A is awarded to the top 7%. So here is the 7%, and we want to know what is the cutoff for this line here that'll actually make 7% in the top band. Now to do that, we use what's called inverse norm. So you're right, we need to find K. I've put K there as the value, such that the probability of X being less than or equal to K is equal to 93%. Now the reason I write less than is because that's the way the calculator is used. We can't actually get the calculator to work out the probability on the right hand side. We can only do it on the left hand side to get our K value. Okay, so if there's 7% on the right, there must be 93% on the left. Now to find the K, we just simply use inverse norm because we're doing the inverse operation. We're using the percentage to get the X value. And you have to put in the probability, which is 0.93, the probability to the left, followed by the mean, and followed by the standard deviation. If you do that, that'll give you the corresponding K value, which has all of that percentage to the left of it. So on the calculator, we go second distribution. You find inverse norm, which is 3. The area is 0.93 to the left of it. The mean is 46. And the standard deviation is 25. And we go paste, enter, and so it's 82.9. So you have to get 82.9 for your test and higher to be in the top 7%. That's what this is saying. Okay, now I'll just show you another way of doing this because I want to introduce the Z distribution. This is very easy because we have graphics calculators. Before we had graphics calculators, we had to use Z scores. And they do come in handy later on where you have to know Z scores. You can't use the graphics calculator to solve something. But this is a good time to introduce it. So I'll do the same question using Z distribution. Now to understand the Z distribution, we have this graph here. I'm going to convert into a Z score. So this transformation, these are the raw scores, these are the X scores. I'm going to convert it using this transformation where Z is equal to X take the mean divided by the standard deviation. That'll convert these into Z scores. Now Z scores is a bit like converting numbers into percentages so you can compare to another class who did a different test, but they had a different total of marks. So this could have been out of 100. You can't really compare it to another class which did it out of 200 unless you express them as percentages. Likewise, you can't compare probabilities unless you express them as Z scores, which are the X scores expressed in terms of standard deviation units, because it's how far away is the score from the mean divided by the standard deviation. So it's in terms of standard deviation. Best way to see that is with some numbers. So If I take, for example, 46 as the mean, and because the standard deviation is 25, that means the first standard deviation after the mean will be 25 plus 46. So that's 71. If we take 25 off 46, take one standard deviation off that, we'll have 21. So that means 68% of the data lie between plus or minus one standard deviation. So 68% is contained in that area there. Now, that's in X scores, but in Z scores we don't use these X values. We're going to use this transformation. So instead of 21, we're going to use Z. We'll put the working over here. So the Z of 21 is equal to that X value, which is using that formula 21, minus the mean, which is 46, divided by the standard deviation, which is 25. Now 21 take 46 is minus 25. Minus 25 on 25 is minus 1. So this corresponds to a Z of minus 1. Now we'll do the 46. The Z corresponding to the 46, that's going to be putting 46 for X. It'll be 46 minus the mean divided by the standard deviation, and that gives 0. So this value corresponds to Z equals 0. The last one, 71, the Z of the X score 71 is 71 take 46 on 25, which is 25 on 25, which is 1. So that's a Z of 1. You can see that originally I put in plus or minus one standard deviation unit. And you can see in Z scores, that's what they are. It's plus Z is 1, and then minus Z minus 1, and in the middle Z equals 0. So when you apply this transformation, that transformation there, you will always convert the mean, which in this case is 46, into 0 as a Z. You'll convert the first standard deviation to the right to Z equals 1, first standard deviation to the left to Z equals minus 1. This is called standardizing the normal distribution, and we can now use this to compare to any other distribution. Now we'll do the same question then using Z scores. So way we do that is we want to know what proportion has 93% to the left. So using Z in the graphics calculator, we could actually say that the Z value, the K in terms of a Z value, is equal to the inverse norm of the probability to the left, which is 93%, and the mean for the Z distribution is 0, and the standard deviation is always 1. That's what we've got here. It's always 0 and 1. Now if you do that on the calculator, so if we go inverse norm, so second distribution, inverse norm, which is 3, and the area is 0.93, but this time we're using 0 as the mean and 1 as the standard deviation, and we go paste, the answer is 1.48. So this is 1.48. Now that's the Z corresponding Z score. If we want to get what the X score of that is, we just have to do a bit of algebra and use that transformation going backwards. So putting down Z, I'll put up a new page, hang on. So converting that using the Z distribution, the Z transformation formula, we'll put that down. Z equals X take mu on sigma. We found the Z to be 1.48. The X is what we're trying to find. The mu is 46. The sigma is 25. So to find the X, we're going to multiply that by 25, and that'll be x take 46. So on the calculator, 1.48 times 25 equals 37. So 37 equals x take 46. Take 46. And now we add 46 to the other side. Opposite of minus 46 is plus 46. And so we get 83. And that's the exact same answer that we got up here when we did it the short way. We got here 83 as the score above which 7% are going to be. Using the z's, we got 83 z's and converting back to x. That seems a very long way of doing it, but the reason why it's done is because they used to use z tables. So they used to do something like this. It's good to be aware of the tables. They're back here. So the old way I used to do is you look up 93%, because that's to the left. So in this table here, the 93%, I'll just bring up the pen so you can see that. Ink squared. Okay, 93% is sitting around about, it's in between there, 93%'s there, that's 92.9. We'll take this one here. Now to read this, you look at the top and the bottom. So going back to that 93, which is sitting right there. You can see that corresponds to a Z of 1.4, and this is the second decimal place, so it's 1.48. A Z of 1.48 will give a percentage to the left of 93%. 1.48. Now if you look at the top of the graph, you can see that's why they've got the left shaded in. So when A is 1.48, we have 93%. Okay, so let's compare that back to what we got here, 1.48. Let's see if we got the same, and you can see it's there. That Z of 1.48, and then you go through that procedure and get your 83. So that was the old way of doing it. Now you don't really need to do it for this question, but we're going to need to do it for the next question. And so we'll go back to now the textbook. Back to 7F6, the application. So we've done question 1, question 4, two ways, and now 5, 6, 7 are similar to that. And now I'm going to do question 8 using z-scores, which is the only way of doing it. And this is the last one to do. This finishes the course. Okay, so question 8, you've got two things here. You've got the probability that x is bigger than 80, so a score is bigger than 80, is 10%. You've also got the probability that a score is less than 30, is 15%. Doing that as a sketch, we're saying that bigger than 80, there's 10% of the people. Getting a score less than 30, there are 15% of the people. From that information, we need to find what mu and sigma are. Now we can't use the graphics calculator without z-scores, because we need the mean and standard deviation, but the z-score, we already know the mean and standard deviation is 0 and 1. So first of all, we're going to convert these all to z's. So the first one, the probability of greater than 80 is 10%. We're going to do the inverse norm to see what the corresponding z value of 80 is. So we go the Z, the corresponding Z value for 80 is inverse norm of the probability to the left, which is 90%, comma 0, comma 1, because it's always mean standard deviation. And we'll get that from the calculator. Likewise, we're going to do Z of 30, which is the inverse norm of the percentage to the left, which is 15%, comma the mean, comma the standard deviation. So we'll get those two values now. So we go second distribution, inverse norm, and to the left we have 90.90, and we got 0 and 1, paste. So for that value we've got 1.28. And now for the 15% one, second distribution, inverse norm. This time we're doing 15%, so 0.15, same 0, 1, paste. That one gives a value of minus 1.036. Minus 1.036. These are the corresponding Z values for these two X scores. Now we can actually use the transformation formula. Transformation formula is Z equals X take mu on sigma. So using the first one, we'll call this equation 1, equation 2. Using this for equation 1, it will be 1.28, because that's the Z, equals the X value. Now that corresponds to the X value of 80, minus, now the mu we don't know and the sigma we don't know. We don't know the mean and standard deviation for the raw scores. That's equation 1. For equation 2, we've got the Z score minus 1.036 equals the corresponding X score 30 minus mu on sigma. Equation 2. We have to solve these two simultaneously and we then get mu and sigma. To solve them simultaneously, we want to get rid of the fractions, so we're going to times both sides by sigma. So equation 1 becomes 1.28 sigma equals 80 take mu. Equation 2 is minus 1.036 sigma equals 30 take mu. Now to eliminate mu, we're going to just add these two equations. Take these two equations, because then it'll be minus mu take mu, which is minus mu plus mu, which is 0. So we're going to do 1 minus 2. So 1.28 1.28, and we have minus, which is plus 1.036 equals 2.316 sigma, and that equals 80 minus 30, which is 50, and minus mu minus, which is plus mu, is 0. So we have that equals 50. Now to solve for that, we divide by 2.316, so that's 50 divided by 2.316. So on the calculator we have 50 divided by 2.316, and that gives us an answer of 21.6. So we've just found our standard deviation. So we can substitute this back into any one of those two equations. So let's say sub into 2, and so we have minus 1.036 times by 21.6 equals 30 take mu, and so we'll take the plus, we'll add u to the other side and get plus mu, and we'll add this to the other side and get 30 plus all of this number here, 1.036 times 21.6. So we can put that in the calculator and we've got our mean. So that's going to be 30 plus 1.036 0.036 times 21.6, and so our answer is 52. That's our mean, 52.4. Okay, so we have a mean of 52.4, standard deviation of 21.6. We couldn't have got that if we didn't know the Z distribution and Z score transformation, this bit here, because we don't have mu or sigma in the question. Okay, so you could practice some of those other questions. I've given you the three major types, so 1, 4 and 8. You can try the ones in between. So here's 2, 3, 5, 6, 7, and there's 8, 9 and 10. You can pause it and come back for the solutions. And here are the solutions here for 7F6, 1 through to 10.